Hey guys, thanks for tuning in. Hope you're doing well today. This is just going to be a short video, just kind of recapping the notes that we took in class today. It's only one page. You can see I'm done by the bottom of the page. So it won't take too long, but just to kind of walk through a couple of these ideas, especially in case you weren't here in class today. So we're talking about conditional probability and the idea of independence. And we've been dealing with this conditional probability, so-called probability of A given B, and what that means. So today we're kind of summarizing what that means as the probability of A happens, assuming that B has already happened. All right, so it's really talking about the probability of A, but in the context that some other event has also already happened. So that's what the conditional probability means. B is like the condition. And so A has happened given that B has already happened. That's what that means. So here's the actual formula that you use to calculate the probability of A given B. And it's a simple probability of A and B divided by the probability of B. So now you remember our phrase, the sample space. In this situation right here, the condition B turns out to be kind of the sample space for the problem. So A and B happens as a subset out of the entire space of sample space of probability of B. So we're taking that fraction, the fraction that A and B happened, divided by the probability that B happened. So that's how you calculate the probability of A given B. It's really about the probability of A in the context of having B already happened. So if the probability of A equals the probability of A given B, then we have said that A and B are independent events. What this is saying is that the probability of A happening is not affected by the probability of B already happening. It's sort of like if you just kind of covered it up. Well, the probability of A equals the probability of A. But so we're saying then that the probability of B happening doesn't change whether or not the probability of A happens. And that's what it means to say that they're independent. All right? So one of the other things that you may recall from the past is that the probability of A and B is equal to the probability of A times the probability of B. Okay? So now, if you recall precisely what our conversation was at that time, we said, or at least I did, I said, well, usually, or maybe, or sometimes like that. There was this a little asterisk here on this so-called multiplication rule. The probability of A and B equals the probability of A times B. This was called an intersection, if you recall our term there. It's an intersection of A and B, and you just multiply probability of A times the probability of B. But if you put that into this formula right here, the conditional probability formula, replace the probability of A and B with probability of A times the probability of B, over probability of B means that it just equals probability of A. So are we saying then the probability of A given B always equals the probability of A? Well, no, that's not always the case. So this substitution right here means something actually very important. We're ready now to kind of finalize what this asterisk means here. All right? So that multiplication rule that we had, the probability of A and B equals the probability of A times the probability of B. This is only true when A and B are independent events. All right? So it's not always going to be the case that the probability of A and B is equal to the product of those two probabilities. That's not always true. It's only true when A and B are independent. This means that this is actually another way to test whether or not A and B are independent, depending on what kinds of information you have given or what you have to work with. It's possible that you may determine whether or not A and B are independent events by comparing these two things. Okay? So that's just the context here. It's kind of a new definition or an extra definition of the word independent or independent events in probability. And so if this multiplication rule holds true, that means that A and B are independent, just as if this conditional probability rule is true, that means A and B are independent, okay? If this is true, then this is true, that kind of thing. And if this is true, then this is true. So these are two different ways, totally different ways to determine whether or not you have independent events. And remember, the opposite of independent isn't dependent. The opposite of independent events are associated events. So if they are not independent, that means that the probability of B somehow affects the probability of A. Those two events then are associated mathematically, all right? Okay, so that's kind of a quick recap of the video. If that makes sense, that's wonderful. If you have questions, if I was confusing in this video, please just write me a little comment in our forum here for discussion. Okay, thanks. Have a great day. Bye.